Welcome to part 5 on inverse functions. Let's take a look at some evaluation exercises for cosine. The first thing we need to remember is that cos inverse of x has a domain from -1 to 1 and range from 0 to pi. And it might be helpful to draw a picture, so we'll go ahead and do that. We're putting an input of something inside. It's a length. And we could get that length by doing cosine of some angle. We know that cosine of some angle is equal to -√2/2. We don't know what that angle is, but if we take the arc cosine of both sides, we could figure it out. So let's go ahead and draw approximately where that -√2/2 might exist. Let's say it's about there. If this is -√2/2 in the x direction, we could have angles either in the second or third quadrants. Remember that we can't have angles in the third quadrant because that doesn't work for a range. So we need to pick the value that is in the range from 0 to pi. Remember that -√2/2 will be the angle theta equals 3 pi over 4. Let's take a look at cos inverse or arc cosine of 7/9. Since this is a number, it's not one of the ones we've memorized. We'll go ahead and use our calculator. I'm going to first check my mode and make sure I'm in degrees. Then I will take second cosine, which will give me the inverse cosine of 7 divided by 9. And that gives me an angle of 38.94. I'll round it up to 39 degrees. The next one is the arc cosine of 0. Well, if I draw a circle and my input for x is 0, that's going to be either at pi over 2 or 3 pi over 2. We can't use the 3 pi over 2. That one is not in the interval that is acceptable. So then we will take pi over 2. Let's take a look at cosine inverse of cosine of 5 pi over 4. If we were to just look at the rules, we would say, oh, well, cos inverse of cos of 5 pi over 4 clearly is just the angle out. That gives me 5 pi over 4, but 5 pi over 4 is not on the interval, for the domain of cosine. because remember we've restricted the domain from 0 to pi. So we need to think about what that would look like if we have our unit circle and we draw an angle at 5 pi over 4. That's going to be a reference angle of 45 degrees, or pi over 4. And if I were to look at how far to the left that's going, it is in the x direction, negative root 2 over 2, which is also equivalent to an output in the second quadrant. So we can say that the value for which this is in the domain would be equivalent to 3 pi over 4. So we can say that the angle that would work for an output in the domain would be 3 pi over 4. But this domain is not on the interval from 0 to pi. So we either have to find an equivalent angle in the domain, or we have to throw it out. In example E, we have cosine of cos inverse of negative 1/2, and we can just say by the cancellation property, we get negative 1/2. That one was quite easy. This next one is sine inverse of cosine of 4 pi over 3. So it would be a good idea to figure out what the inside is equal to first. So if we take cosine of 4 pi over 3, first let's find the angle. If I break this up, this first 0 to pi, into thirds, that'll be 1, 1/3, 2/3, 3/3 to pi. And then I'll break this third quadrant up into thirds. So that's 4 pi over 3. And if I look at the x values for which 4 pi over 3 exists, I know that 4/3 is equivalent to negative 1/2. So the cosine of 4 pi over 3 is negative 1/2. So now I need to take that value and put it into my sine inverse. So once I've figured out that I need a value of y equals negative 1/2, I can then determine the angle off of 0 in the clockwise direction, which will give me an angle that is equal to negative pi over 6. That should give me an output, or a length in the y direction, of negative 1/2. I can check this on my calculator by doing sine of negative, make sure you're in radians, pi divided by 6. And I get negative 1/2. This is extremely critical to understand. You have to keep track of what the numbers going in represent, what the numbers coming out represent. It's very important to recognize that the negative 1/2 is a length. And when you take the inverse sine or arc sine of negative 1/2, you get an angle. In goes a length, out comes an angle. So let's see if this will make sense. We take sine inverse. Let's actually put it back in degree mode first so that you can see that negative pi over 6 corresponds to degrees. we're going to take the arc sine of negative 0.5, and we get negative 30 out. Negative 30 is an angle in the counterclockwise direction. Now this last one we have is cosine of sine inverse of negative 1/2. We have a length going in. We should be getting an angle out. And then cosine of that angle, whatever we get, we don't know it yet, should give us a length. So our goal is to find the length. But it's a combination of sine and cosine here. So first let's figure out what angle will give us a y value of negative 1/2. Given the restrictions on sine, I can only have values for y equals negative 1/2 between negative pi over 2 and pi over 2, which means that my angle must be in the fourth quadrant, and I'm trying to figure out what the angle with an output of negative 1/2 would be. Well, we already found that to be a negative 30 degrees, or negative pi over 6 in radians. So now we have cosine of, we'll just go ahead and use degrees, negative 30 degrees, and we need to now figure out what that is in the x direction. Now we're looking for what the x coordinate of this point is. We already know that y is negative 1/2. So what is the x direction that gives us a negative 1/2? Well, we happen to know that x is positive, and it's a quite large number. It's root 3 over 2. So the cosine of negative 30 degrees is root 3 over 2. Now, I've calculated all these values in the fourth quadrant, but remember that cosine only exists between 0 and pi. So what is the equivalent output for the cosine function? Well, that just means that whatever we had down here is actually not an angle of negative pi over 6. It's actually an angle of pi over 6, which gives us an equivalent output in the x direction. When we say it's root 3 over 2, we must also recognize that this measure is in the first quadrant.